So, we're now recording. If you still need help, the best thing to do is going to be to watch this video. It will not be up until the end of the day tomorrow because I don't want the kids in chapter 4 to be able to watch it tonight. So this is kind of cool. I'm talking to your future self because think about it. You, 2 days from now, are a future version of who you are right now.
That's kind of scary.
Kind of a, yeah. Mind blow. So, I am speaking to your future you. Number 1, the question was how many planes can be drawn through any 3 non-collinear points? We had, even though this is review from chapter 1, we also had, chapter was in chapter 1 and we had in chapter 2. There were a number of postulates that we had. There were 5 postulates and about points, lines, and planes. And then there were 2 postulates about intersections. So right from that list, it said through any 3 non-collinear points, there is exactly 1 plane. So you might want to leave, so you might want to write that. You may also want to come in at some point during lunch or after school, and I can show you exactly where those postulates and theorems are in the book. And you can write them down. But one of them says, through any 3 non-collinear points, there's exactly 1 plane. That's why it's B. Number 2, which 3 points in the figure are collinear? Collinear means the same line. You don't remember what collinear means? You want to write down. Same line. F, E, and G are all on the same line. So that's why the answer for number 2 is J. Number 3. We're basically talking about the intersection of 2 planes. From those postulates that we end up learning in chapter 2, we know that 2 planes always intersect in a line. Plane D, so the plane that contains B, C, and D is this plane here. It looks like the side of a triangle. It looks like a triangle, like the side of a triangular prism. Remember, planes extend in any direction. It intersects with this plane at line BC. Even though that's a line segment, it would continue to align. Okay?
I have a question on that.
Yeah.
So you can't do another side of the triangle for a different plane?
Correct. A side of a triangle, you can't use triangle BCD because that plane is actually continues on.
So if you
The key, okay, so the key there is it's the plane that contains B, C, and D. So even though in that drawing it looks like a triangle, that plane continues on. Okay?
Do you have extras?
Extras
They were
of
right
the
here.
review. In one of the folders there, it's not labeled, I'm sorry, but it's there. So now do we understand why it's B? Do you get why it's B? First of all, it's a line, not a line segment, correct? And that's BD, so that's not where they meet. Okay. For number 4, you're given that A is in between Y and Z. When you had this on your test back in chapter 1, we actually told you to write that drawing. Okay? At this point on the final, I'm not going to remind you to write that drawing. I would expect that after a semester of geometry, A is between Y and Z, that you could draw that drawing. Okay? If you have trouble with that, then you write something on your reference sheet. You can even write the example and put that on. Okay? Well, and that's not a bad idea. If you're going to write just about everything on here, because the test, if you've learned, it's the same kind of questions in the same order. So if I have to draw a little drawing for number 4 on the review, Maybe it's number 3 on the test. Maybe it's number 5 on the test. But I'm probably going to have to draw a little drawing. What we're saying is 5.5 plus 2x is equal to the total of 41.5. So when I solve for x, I'm going to subtract 5.5 from two sides. I get 2x equals 36 and x equals 18. But did they ask me to find x? They asked me to find AZ. AZ is 2 times x. So you have to plug it in. Or you could have realized that when you got to here and you got 2x is 36, AZ is 2x. Now on the actual final, I don't know if that step works as well. You might have to solve for x and plug it back in. Okay? Yeah. Well, how I got 2x equals 36. So I divide both sides by 2, I get x equals 18. So I want to find AZ, right? AZ is equal to 2 times x. So 18 times 2 is 36. No problem. So for number 5, I need to do the distance formula. You probably don't have it memorized, which means you want to write it on your reference sheet. Now, even though it says x2 minus x1, I can do these in either order. So even though a lot of kids will say, well, that's x2 because that's the second pair, I tend to just subtract in the order they're there because my eye reads left to right. So I do 2 minus 5 squared plus 8 minus 3 squared. 2 minus 5 is negative 3. And negative 3 squared is 9. If you did it the other way, if you did 5 minus 2, you would get 3. And 3 squared is 9. So negative 3 times negative 3 is positive 9. Or 3 times 3 is 9. On this one, on the y's, 8 minus 3 is 5. And 5 squared is 25. Okay? 9 plus 25 adds up to 34. So your answer is the square root of 34. So writing distance formula down is probably something everybody in here needs to have written down on their paper. Okay? Even if you think you know it, it might be good to have it because what if you get all nervous the day of the final test and you, oh my God, I don't remember, is the x2 plus x1 or x2 minus x1? It's just good to have it written down. There's no harm in having it written down. Another one you probably need to write down, next problem, is the midpoint. The midpoint is where you take the two x values, you add them together, and you divide by 2. And then you take the two y values, you add them together, and you divide by 2. Basically, when you're doing the midpoint, you're taking the averages. Because average means in the middle, correct? When you take an average in math, you're taking the thing in the middle. So, 8 plus negative 6 divided by 2. 8 plus negative 6 is the same as 8 minus 6, correct? And 8 minus 6 is 2. And 2 divided by 2 is 1. Now over here, 5 plus 2 is 7. And 7 divided by 2 is 7 halves. If you put 3.5, I will accept it. If you messed it up and put 4 like Mrs. Falk did, it would be wrong. You guys missed the fun at first period, which is where Mrs. Falk makes mistakes.
I kind of saw it.
That's why I don't video during first period. Yes. I got 3 wrong on this, so I actually still got an A, but not 100. Mr. Parks got 100.
No, I got 29 out.
Oh, you got 29 out of 30?
I got number 12. We'll get there.
Number 12. Okay. I say all the time, get an A in this class, we might get 100. So for number 7, which pair of angles are supplementary? So one of the keys here would be what makes a linear pair? Because a linear pair, they're equal. If I add them together, it's 180 degrees. So if I start looking, ABE, so that would be that angle, and CBD. Those aren't a linear pair, are they? What kind of angles are they, by the way? Vertical. I point this out because a number 1 angle problem in all of my classes, and I can see it even on tests we do now, is kids not recognizing vertical angles. Whenever you have 2 lines that make an X, those are vertical angles. We want supplementary. So in this case, we're looking for a linear pair. If I look at ABC, well, ABD is a straight line, but these aren't a linear pair because ABD is overlapping ABC, correct? That's why B is not the correct answer. Okay? Sorry, G is, yeah. G, that's why G is not the correct answer. The correct answer is H. ABC and then CBD. ABC are CBD and CBD are adjacent angles. They share a side, and their non-shared side makes a straight line. So for number 8, what angle is vertical to ABE? When you're talking about vertical angles, you want to focus on that pair of intersecting lines. Anytime you see lines intersecting and they make an X, I want you thinking vertical angles. So what's vertical to ABE? CBD. Yes.
So vertical angles are just intersecting.
They're made by intersecting lines and they're kind of like the opposites. So, and I know you weren't with me. So if I have 2 lines that intersect, let me highlight, this will work better. Those yellow angles are one set of vertical angles. And the blue set is another set of vertical angles. And I know that you guys have a hard time with this. Chapter 4, one of the proofs that was on the Chapter 4 test was proving triangle congruence, and there was a pair of vertical angles there. And between 3 classes, so 55 students, maybe 3 people were able to pick out that those are vertical angles. Okay? Hint, hint. When lines intersect, they create vertical angles. Hint, hint. That was a proof on your Chapter 4 test. You have a final coming. Hint, hint. Just saying. Problem number 9. A lot of students are still struggling. What is this symbol in number 9? Perpendicular. Okay? I specifically, when I made the review and made the final, pulled this question because I want to make sure we know this symbol. Perpendicular means the lines are going to intersect and form 90-degree angles, correct? So, CBF would be a right angle. It would equal 90 degrees. So that means 6x plus 18 has to equal 90. What would I do next? Subtract 18 from both sides. -18 is 72. I divide both sides by 6, and I get 12. So we have to go back and use our algebra skills there. So now let's talk about number 10. I have, still using that drawing, angle ABC. That's that angle there, correct? And EBD. What's the relationship between angle ABC and EBD? Yes. And why are they equal? What's the vocabulary word? Not because they're perpendicular, because they're vertical. Okay? Look, this angle is created by these sides, correct? And this angle is created by these sides. So it's this space in the middle here and this space in the middle here. If that color coding helps you. So that means I have to write an equation setting them equal to each other. Okay. So this is an algebra skill, correct? A lot of my students in algebra have problems solving variables on both sides of the equation. I think I'm going to put that one on there. Actually, I think I'm going to pull your equations off of your final because we're already taking your final and put those equations on their final. Just ask them to solve the equation. So I'm going to subtract the variable with the smaller coefficient first. 9 equals 3x minus 9. Then I'm going to add 9 to both sides. 18 equals 3x, x equals 6. But they asked me to find the measure of ABC. They didn't ask me to give them x, did they? So you got to be really careful about what they're asking.
Okay, so say that you find x and then you plug it in and then you find a number. Well, what if I asked you to put x instead of x?
Oh, so like if you put x equals 33, well, a few things. First of all, I know what you do, what you need to do there, but on your test there'll be multiple choice. So you'll just be picking the letter.
And so if you did, instead of subtracting the x first, would you added 9 first? Would you make the
Okay, so if you added 9 first, you would get the same answer. The reason that I keep telling kids to get rid of the variable, the the coefficient, the smaller coefficient first, is because what I'm doing now is I'm turning it into just a two-step equation. And we're usually pretty good at doing two-step. If I have the variable on both sides, then I still have a variable on both sides. So let me explain to you what I'm afraid of happening. This is why I don't like doing it this way. Okay? What a lot of kids do, they'll see that plus 9 there, right? And if they don't use it, this is what not to do. Okay? Is they'll subtract 9 from both sides first. Usually what they'll do, because they see plus, they'll subtract first. And they'll get 4x equals 7x. And then they'll not be happy, because what they'll want to do next is subtract the 4x next. Because they don't want to subtract the 7x, because they already start to realize then when I subtract 7x, I'm going to get a negative here. So usually what I see happens, then they try and deal with the, and then they get a 0 over here and it all goes back. Or exactly what I did here, right? It's a negative 18, but they forget to bring down the negative. Or even if they bring down the negative, because there's a negative there, they end up going with x equals negative 6. So what starts to happen when you do this is I find there's a lot more places for you to mess up your sign. Now if you did it correctly, negative 3x equals negative 18. So x equals 6. So you get the right answer if you don't mess up your sign, but my experience is that's where kids will end up making mistakes, is they'll mess up the signs. Okay? So I take the 6, I plug it back in here. 4 times 6 is 24 plus 9 is 30. Got it? So then I'm going to stop this.